Earth is not a solid ball. It has layers. The outer layer is the crust. Below that is the mantle. Deeper still is the core. The core is very hot. It is mostly iron and nickel. The crust and the upper mantle form the lithosphere. The lithosphere is broken into large pieces. These pieces are called tectonic plates. They float on the softer, hotter mantle below. This layer is called the asthenosphere. The plates are constantly moving. They move very slowly, but over millions of years, they have changed the face of the Earth. Mountains, oceans, and continents all exist because of these movements. Understanding Earth's structure is key to understanding plate tectonics. Let's delve deeper into this fascinating theory. The theory of plate tectonics explains how the Earth's surface is shaped. It was developed in the 20th century. Scientists noticed that continents seem to fit together like a puzzle. They also found similar fossils on different continents. Plate tectonics theory says that the Earth's crust is divided into plates. These plates float on the semi-fluid asthenosphere. They move because of convection currents in the mantle. Hot material rises from the deep mantle. It spreads out, cools, and sinks again. This cycle drives the plates. There are about 15 major tectonic plates. They include the Pacific Plate, the North American Plate, and the Eurasian Plate. The edges where plates meet are called boundaries. These are places of intense geological activity. By understanding plate tectonics, we can explain many natural phenomena. This includes earthquakes, volcanic eruptions, and mountain formation. There are three main types of plate boundaries. They are divergent, convergent, and transform boundaries. Each type causes different geological events. Divergent boundaries occur where plates move apart. Magma rises to fill the gap, forming new crust. This is called seafloor spreading. Example, Mid-Atlantic Ridge. Convergent boundaries occur where plates move towards each other. One plate is forced under the other, creating trenches and volcanic arcs. Example, Andes Mountains. Transform boundaries occur where plates slide past each other. This causes earthquakes. Example, San Andreas Fault. Understanding these boundaries helps predict geological events. Section 4. Real-world examples of plate boundaries. The Ring of Fire is a major area of convergent boundaries. Many volcanoes and earthquakes happen here. The Himalayas are an example of a convergent boundary. The Indian Plate is colliding with the Eurasian Plate. The Mid-Atlantic Ridge is a divergent boundary. The Eurasian Plate and the North American Plate are moving apart. The San Andreas Fault is a transform boundary. This movement causes frequent earthquakes in the region. Section 5. The role of plate tectonics in earthquakes, volcanoes, and mountain formation. Earthquakes happen when plates grind against each other. The stress builds up until it is released as seismic waves. This sudden release of energy causes the ground to shake. Transform boundaries like the San Andreas Fault are common sites for earthquakes. Volcanoes form at both convergent and divergent boundaries. At convergent boundaries, one plate is forced under another. The sinking plate melts and forms magma. This magma rises and erupts as a volcano. At divergent boundaries, magma rises to fill the gap between plates. Mountains are created by the collision of tectonic plates. At convergent boundaries, the crust is pushed up to form mountain ranges. The Himalayas are a prime example. They are still growing as the plates continue to collide. Understanding these processes helps us comprehend how the Earth's surface is constantly changing. Section 6. Significance of plate tectonics in predicting natural disasters. Knowing about plate tectonics is crucial for predicting natural disasters. Earthquakes and volcanic eruptions can cause massive destruction. By studying plate movements, scientists can identify high-risk areas. Seismic activity is monitored around plate boundaries. This helps in giving early warnings of potential earthquakes. Volcanic activity is also closely watched. Changes in gas emissions and ground deformation can signal an upcoming eruption. Building codes in earthquake-prone areas consider plate tectonics. Proper construction can reduce damage and save lives. Countries like Japan and Chile have strict building regulations due to their location on active plate boundaries. Understanding plate tectonics also aids in disaster preparedness. Communities can be better prepared for evacuations and emergency responses. Section 7. Summary of the importance of plate tectonics theory. Plate tectonics theory has revolutionized our understanding of Earth. It explains the movement of continents, the formation of mountains, and the occurrence of earthquakes and volcanoes. This theory has provided answers to many geological questions. The study of plate tectonics is essential for predicting natural disasters. It helps us understand where and why these events occur. This knowledge is crucial for minimizing damage and saving lives. It also informs construction practices and disaster preparedness. As we continue to study Earth's dynamic crust, we will uncover more secrets. The theory of plate tectonics will remain a cornerstone of geology. It is a testament to the ever-changing nature of our planet. By understanding plate tectonics, we gain insight into the powerful forces shaping our world.